Pursuing my executive PG program in data science from IIIT Bangalore and Upgrad. And this presentation is regarding my Python lab video submission. So let's just not waste the time and start with our presentation. So the agenda here will be, first we will be understand the problem statement. Secondly, we will check the solutions, approach explanations, which include the data structure, the solution evaluation, which is fast and efficient. Thirdly, we will check the coding part. And finally, we will end to the conclusion. So moving to the next slide. Here is the problem statement. We are given a list that can contain positive and negative integer. We need to find two elements such that their sum is closest to 0. For example, we are given a list -4, 7, 6, 2, -5. The two elements with the sum closest to 0 will be -5 and 6. We will be also provided some hints. That is, the sum can be either positive or negative, but the absolute distance of the sum from 0 should be considered to find the sum closest to 0. We will assume that the maximum possible sum of any two elements in the list is 100 billion. Inbuilt sort may be helpful in this problem. The input format will be a list of integers, and the output format, the output contains the two elements with the sum closest to 0. Here are some sample test cases. The first is the -4, 7, 6, 2, -5. So here the output will be -5 and 6. Second, the input list will be -50, 34, 19, 24, 33, 10, -46 and -38. So the output here will be -38 and -34. So the next, on the next slide, we will land up to the methods we'll be using here. So the first method will be here, will the code. Find the approach I am explaining you. Find the sum of each element with each other element in the list and store it in a dictionary. Finally, we will return the minimum sum element from dictionary key in a sorted tuple. The algorithm and pseudocodes are as mentioned below. We will define a function def closest underscore to underscore 0 list 1 with a parameter input list 1. We'll create an empty dictionary which will be used later to store keys as elements. Value sum. Checklist validation. If the length of the list is greater than 2, then valid else invalid cannot compute the sum. We will initialize the loop until the list last element or length and calculate the sum of each iteration. For each iteration, calculated sum element and absolute sum value need to store in an empty dictionary. We will apply to sort all dictionary item on basis of values which will sort with minimum sum values. We will return first key from the dictionary and sort elements within the key, also convert them into tuple to get the final output. The auxiliary space are 0, 1 and time complexity 0 and 2. Now to the next slide. The second method which we'll be using here, using sorting, using quick sort algorithm. The algorithm and pseudocodes are as mentioned below. We will sort all the elements of the input list using the quick sort algorithm. We'll use two index variable I and R to transfers from left and right end respectively. We'll initialize I as 0 and R as n-1, where n is the length of input list. Sum equals to input underscore list I plus input underscore list R. If sum is negative, then L equals to L plus 1. If sum is positive, then L equals to R minus 1. We'll keep a track of minimum sum. Repeat step 3, 4, 5 and 6 while I is less than R. The auxiliary space here is 0, 1. Time complexity will be complexity to start plus complexity to find the optimum pair equals to 0 and log n plus 0n equals to 0 and log n. Now moving to the next slide will be the coding part. So here from looking at the code itself, it is very self-explanatory, but still I'll be explaining. We will go into deeper. So this is the first code for the first approach that we discussed, which is going to be the first approach. Now let's have a look at the code. So we start by defining a function which is closest to 0 and also created an empty dictionary sumd. Now the first thing we check if the length of input is less than 2, we will print invalid input, as we cannot do a sum of two elements if there are not enough elements in the given input or given list. Secondly, we will initialize loops to calculate the sum. So there will be two loops that will be running from I in range, length of L minus 1, and for j in range, I plus 1, length of L. Now to add all the values in empty dictionary, here's the code for it. And once we have added the sum, then we will sort all the dictionary items on the basis of values, for which will we use sort function. Sumd dot item key, for defining the key, we will use a lambda function, lambda kv, where kv is the first kv. Kv is going to be the first index. Now finally returning those two elements having sum closest to 0 in tuple format. So this is the code for it. So the Python data structures used here are list, tuples, and dictionaries. Now let's have a look at the test cases. There are two different test cases. One with the input list, this, and the another is this. We will check the input list one. Now this is the output which is as expected, and another is output is this, which is also as expected for the test case 2. Now we'll move to the next slide, the second method. Now this is the quick sort function. For this function is particularly used for sorting purposes, and this is where our main function will start. Function to start the minimum sum pair. So we'll start by defining a function minimum sum pair, where n is going to be the list of in length of the input sum is going to be 0, and minimum sum is going to be 10 to the power 9, which is 1 billion, again as something. This is already provided in our assumption, in our hints. We initialize left and right with 0 and n minus 1. Then this is the loop where we check if the elements present in the list are sufficient to do a sum or not. If it is less than 2, then the output will be invalid. Now we will sort by sorting all the input in the list elements in the list by calling the quick sort function, which is right here. Now the list is in the list. Now we will check if the absolute sum is less than the absolute minimum sum. Then minimum sum is going to be someone minimum, left is going to be left, and minimum right is going to be right. If someone is less than 0, then left is going to be left plus 1. Else, if right is going to be right minus 1. Finally, we will return left of list 1, right of list 2. So this is the last part which we have completed. Now finally jump to the conclusion here. So we have seen here that both the methods were working fine and the output is as expected. Also, these two methods are not the only method from which we can expect the solution. There are other methods as well. That's all from me. Thank you.